think we're live now with more audio. That's probably better. All right, what was I saying? I applied the devil's juice to the pads. I want to clean those pads up. And to do that, I'll use the braid and a fan because this will stink. And I've promptly soldered the braid to the pads. The idea is I want to get as much of the God, that's a heat sink. The leaded solder off. We have some clean pads. And so that the new chip will go down flat. Those are the pads that I had a lot of trouble getting the leaded solder onto. All right. I'm going to call that clean. You can tell on the screen how clean it is. It's super, super clean. Hello, viewer. Can you hear me? I might share this link and can I do that? Watching me share a link. That's going to be fun. All right, you're missing all the action over here, which is me texting with people. Like that's what live streaming is all about. All right, cool. Let's get back to actually doing stuff and turn that fan off. Someone is texting me. Someone watching. Luke, are you watching this? Anyway. All right, I've got that chip off. I've got it cleaned up. It doesn't look clean, but there is just a lot of flux on there. Now the trick is to remove this good, well, should be good analog devices chip off here, which is totally overpowered for what it's being used for on this side of the board and move it to that side of the board. Wrong camera. Move it from there to there. Anyway, who's texting me? Oh, okay. I should probably label which camera is which. So let's go back to the microscope. Okay, microscope. Let's get you back in action. All right. I'm not looking forward to removing this chip here. It has a lot of, if you look at this one here, there are a bunch of passives around it, and they're not too close and crowded. Down here, where's my pointy poker? This one has more passives that are likely to flow away. Anyway, let's do the same thing again. Apply a flux, try putting on some lead free. Who's beep booping me? Something's beep booping me. Anyway. Replacing the leaded or the lead free with leaded. Do you guys want a closer view? We could zoom in. Would that be compelling video content? Certainly make my job a little easier. Let's zoom on in. That's too big for you, but it's just right for me. All right. Okay. I might switch tips to a finer tip. I've got a knife tip. I could do that. Yeah, let's try the knife tip. Why not? It's totally inappropriate usage of a knife tip, but why not? Fan back on. Let's go to town. I mean, I don't know how much help it was mixing in the leaded in here, given the size of that thermal pad underneath. But I'll take all the help I can get. And I don't even think I'm getting much in here right now, to be honest. It's the wrong tip shape. Let's switch tips again. Switch tip. Oh, there we go. That's getting in there. Do I have room? Definitely bridging, but that's fine. We just want to decrease the concentration of the lead-free solder. I think I've said that fact like 17 times. I am, after all, just talking to myself. All right, I think that's good enough. Now, I'm a little concerned because this is a chip that I want to keep on. So I did have the heat gun at a stupid temperature. I'm not going to say it for fear of getting arrested for how hot I had that heat gun. Let's move this out of camera shot. No, I'm still just a ridiculous temperature, but not stupid ridiculous. Let's see if this ADV 7937, I think it is, wants to come off the board. It's interesting. I think what I'm smelling is, so we had a wildfire come through our farm a couple of years ago when we were still living at the farm in America. And everything that I had over there just smelled like fire because it was the middle of summer, as wildfires tend to be. And I had my shop I designed it for passive cooling. So I left all the windows open and they were high, like the Celestery, is that how you pronounce that word? There you go, we're flowing. I had all those windows open and they were a pain in the ass to shut, and it wasn't high on my priority list when evacuating from a wildfire. So the windows to my shop were all open. As a fire ended up being like a mile away. The thing that captures most of the smell is like all of my cords, the rubber, silicone or whatever, rubber. They all smell like fire. But anyway, why am I talking about that? Because I can smell it right now. This board here that I'm working on was in America in the fire. I think I'm getting some wiggling. Everything seems to be melting here. I can smell the fire on this, but it could be just the fact that I'm burning this board with a ridiculous temperature. Just testing the parts around it just to see if A, if my temperature is too hot, and B, if the heat's getting to where it doesn't need to be. Getting more wigglage with that thermal pad underneath. That's the problem. But now that I did the other one, I'm not too worried about this one. So I do have this at a lower temperature. And I know it's possible. If they got it on this board, you're going to be able to get it off, right? Like that little ball just hanging out there in the corner. Sure, it'll bugger off to somewhere where it'll cause problems. I'm tempted to try and just wedge it. Probably a bad idea. Oops. Keep it in frame. Whatever I do, keep it in frame. Might just rotate it actually. Just so and get the heat from a slightly different angle. That RCA connector up there was sort of in the way of my tweezers a bit. I should have checked the backside of this part of the board. I don't think the heat's going all the way through, but I don't think there was much back here. I think there was only a bunch of passives underneath the FPGA, some decoupling caps and whatnot. Come on, lady. I need to get a different set of tweezers for this job, but I'm worried. Like tweezers with a more flat profile would apply more force and let me twist it a bit. But I worry if I take my heat gun off for too long while I go get my tweezers, it's just going to get cold. And I'm impatient. I want to get this guy off. All right, I'm going to get the right tweezers, or better tweezers, I hope. Tweezers. What do I think will be good for this? I do like the kink angle, but maybe something with a flatter blade. How do these guys feel? Too chunky, way too chunky. These have a flatter blade, but the axis angle is all wrong, but let's try. Before I lose too much heat. Yeah, talking to yourself while soldering under a hot air station is a great way to get a dry mouth. There's a life lesson in there for everyone. These tweezers do block my view, and more importantly, your view. I'm worried that I just killed all of the heat that was giving me progress. Where are the other tweezers? Excellent craftsman blames his tools. The tweezers were fine. He was just being impatient. It's looking pretty dry in there. I'm going to get some more flux. Keep heat in the vicinity. Oh, I am melting the tip of this. Yeah, that's what we need, is we need molten plastic all over this. Great, and this is the chip I wanted to keep well. I think I can clean that up. You can see it rocking. Is that just me? I guess I am operating at a lower temperature than the last one of these chips that I removed. If the chip is rocking, something. God, I hope none of my colleagues see this. I get to work with some really good electrical engineers. Oh, hello, Christian. Send me positive vibes for getting this chip off. No, I feel horrible. Someone's actually watching this. I gave this a cheeky title of Tanda. Hey. Wow, now I know that people are actually watching who know what they're doing. Well, now that I've got company, I can admit a very embarrassing fact, which is that having moved from America back to Australia after spending nearly 20 years, that's what I need to do, is admit an embarrassing fact. Come on, get off there, you bastard. I still get confused between Fahrenheit and Celsius, which is a totally, which is a totally valuable life skill for soldering. I've just realized I've got this off. Yeah, I was trying to save that part. Let me, for those of you who've just tuned in, let me show off fancy computer stuff. How do I do that? There we go. This is a Blackmagic board. I can zoom out. There we go. Both analog to digital, digital to analog video board. It has two of these 4-channel, I think, no, 3-channel analog to digital converters on it. One of them was blown by getting line voltage fed into it directly due to smart things that I did once. There's another one that was down here. No, here, I've got it upside down. This is the one that does component video. This is the one that does composite video. For some reason, they were using the same high bandwidth analog to digital converter to do audio and composite ADCing, which is way lower bandwidth. But they, for bomb count reasons, I assume, they just use the same chip. So I'm just going to switch those two chips around. Now, the reason why I was going, is like, which one was the good one and which one was the bad one? I should have thrown out the bad one. I'm pretty convinced that this one over here is the bad one and this is the good one. And I think the way we can confirm that is the good one is covered in the flux. It's still hot, yes. No, they're both cooled off. But the good one, I think I melted a bit of the tip of the flux dispenser onto it. And so we should be able to see the remnants of that nonsense. And so this one here, which I'm saying is the good one, I can see some green on there, sorry. And the bad one, I'm just going to move to another desk. That's actually what threw me off. I thought it was the input termination resistor. I thought it was an easy failure. I thought it was an easy failure that there's just the input 75 ohm resistor. I'm just going to put that straight in the bin before I get sidetracked. Where are you, 75 ohm resistor? I thought that this is going to be an easy. Oh, you're already looking at that one. Ooh, fancy transition. You can see my bodge job there where I've put in a 75 ohm resistor. I thought that was what was blown, and by fixing that, it was fine. But even when I replaced that termination resistor, it was still a direct short to ground. So I think the input protection or whatever, I assume there's like ESD diode type things on the input to try and save it. I think that died on here. So before I get too ahead of myself, this is where the new one is going to go. Let's look at the site of the old one. There's a bit of carnage there. I am going to clean it up, not because I'm particularly clean and tidy, but there are a lot of shorts from where I was flooding it with leaded solder. So let's try and just clean that up a bit, because who knows what I've actually shorted out. Let's get even more flux on here with my melty flux tip. You know what? While I'm at it, I'm going to switch to the metal applicator. Not that it will help in low temperature environment, but it'll save me the embarrassment of melting another tip onto another chip. All right, let's try and clean this up. How's the audio coming across? Can people actually hear me? I've not actually tested this. Or am I just talking out loud to myself for absolutely no reason? You tried to scroll the picture up. You want to see that's a RCA connector. Audio is good. Awesome. Thanks. Let's try cleaning this up. I've been playing with a variety of different tips today. I've never actually done a QFN package on my own board, let alone replaced one on another board. So I think you both missed my joke at the start of this video, which is fine. But my joke was I've been watching lots of microsoldering videos, and the thing that I learned is you need good camera and good lighting. I didn't actually learn anything about microsoldering. But I guess no, it gave me confidence to just, you know what, fuck it, just give it a go. That looks clean enough. I'll get some isopropyl on that once I'm done with everything else. But I don't see any shorts there, so that's good enough. All right. Let's take a look at the chip itself and see how badly damaged it was by my desoldering attempt. Let's bring you back over here. I mean, the top side is gnarly, but that really doesn't matter. Is there an obvious pin 1 marking? All the things that I should have done before taking it all apart. All right, let's clean up the bottom. Let's give its bum a bit of a wipe. All right. And I might, I'll just try cleaning it up. It's already absolutely covered in flux. I don't know why I'm adding more, but why not? It's relatively cheap. I should have my fan on. I'm mainly just trying to make sure that it sits flat-ish on the board, and I'm worried about, is that the solder bump, or is it just flux? It only has a fair bit of thermal mass to it. That's clean enough. So I didn't think I'd get this far. And the question now is, how do I solder this guy back down? And where is pin 1? No PB. Well, that's not true anymore. Let's get the good chip out of the way. So it's got to go here. Is there an obvious pin 1 marking? I think I see. You can't see what I'm pointing to because I've very zoomed in, but that looks like a pin 1 marking. Do I have solder paste? Yes, I do have solder paste. I was wondering if there was just enough, because I've got a bunch of, I've tried to swap out the, yeah, let's solder paste. Let's just do that. Which is my freshest solder paste. Who knows? They're all sitting in a fridge up here, so it's probably fine. And do I have a shorter tip? No, they're all long tips. All right. Dispensing grade leaded solder paste. I need dispensing grade pliers to open this lid. There we go. Do I need to use the tip? I feel like it's going to waste a bunch of paste, but whatever. Let's just stick it back in the fridge. All right. That tip just looks huge. And I think this solder paste is way dried out. Oh, come on. I picked an old one. It's flowing a bit. But it's been in the fridge for a while. I don't use solder paste a lot. I tend to hand solder my boards when I'm protoing them. I don't know why. I think I still haven't been convinced by the magic of surface tension. It's not making its way down this tube, which is not a very good sign for the freshness of this solder paste. It's not that tiny. I've seen smaller. I might try and see if I've got a better solder paste thing. Because no clean solder paste. Pasta. Come on, camera. So this no clean paste, lot paste, pasta per saldatura, nessuna pulito. Danger. Is this leaded solder? Because that's really the main thing I care about. And if I can't, oh yeah, it is. Tin lead. All right, let's see if this is in any better condition, the solder paste. I wonder if it's just because it's been in the fridge, it's just really cold and flowing poorly, and it's not actually dried out. I read somewhere that you're supposed to keep it in the fridge to stop it from drying out. Yeah. Sorry. I have a friend who's texting me he was going to come over this afternoon to play with some digital audio protocol stuff. And he said he could drop the boards off here because he's going on tour starting next week. He said he'd drop the boards off, but just as long as I don't burn them. Maybe he's watching the live stream too. You know what? This paste is flowing. That's probably way too much. I'm going to to a non-traditional application style. The microscope, which I need to switch to you. All right, there's a gob. Just tell me if this looks horrible. This looks like a really bad idea. I was just planning on smushing it around. It's not even smushing, it's very clumpy. Man, I think I'm just going to get solder bridges everywhere. I'm going to have a bad time. Maybe what I'll do is clean this up a bit, like get it spread around, clean it up, and just leave some then heat this and get some little like pads formed, then set the chip down on that. But I don't know what that'll do with the thermal thing. All right, that looks like way too much. Am I right? That's way too much. What can I clean it up with? What can I clean up my tissues with? You think I have paper towels in here? Nothing. I'm not prepared. Solder sucker? Yeah. I guess that would clean it up. It is technically solder that I want to suck, but I was thinking more of like a Q-tip to wipe. But I think that'll just smear it around. I have tissues. I must have tissues in here. I have a cold, so I must have tissues. I'm just checking to see if they're not like aloe vera impregnated, because I'm sure that's not great for solder. But they seem to be just plain old facial tissues. So is that guy a little loose to you? Did I melt all of these? One sec. I mean, they're all say they're connected. Oh. Sorry, you can't see what I'm saying. It looks like the plastic stake-ons that hold these guys got a little bit melty in the removal phase. That's just smushing it down, isn't it? But yeah, yep. I think you're right, Christian. Question is, how do I get this god awful mess off? Oh, it's really sticky. In all of this, I promise you, I'm going to get pin one in the wrong spot, and it'll be a perfect job with no bridges. Chip will just be off by 270 degrees. How bad does that look under the microscope? Sorry, you couldn't see what I was doing. Yeah, that's beautiful. I'm just going to heat it up and see what happens. I'm going to turn the temperature way down from what it was at. And see if this makes little pads. I don't see either of you typing in all caps, so clearly Either you're not paying attention or I'm not doing something too stupid. A nice solder bridge ready to form there. Actually, I have a different idea. That's much faster. And if I leave the solder paste on the thermal pad, it should melt. Sorry for the very poor microscope video quality. It actually looks really good through the eyepiece. Those all look relatively symmetrical. I'm worried about bridging happening across here. Let's see if I can clean that up a bit more. Let's have a look and see what the other one looks like. Yeah, there's supposed to be a nice margin around there. That margin is full solder paste here. And I think this is my fundamental problem, is that thermal pad is a very good conductor of heat. So I think I will need isopropyl alcohol. This one's empty, so I can throw it in the bin. The finest IPA. I'm just trying to get that excess solder paste off. And spread all those little solder paste balls all over the board where they're going to cause havoc. We can wash them off. Whatever. Doesn't matter what you're saying. Let's flood this with isopropyl and just wash those balls away. Thank you, Tanda. Wow, awesome. I assume the dot was pin 1, but yeah, awesome. All right, that looks more presentable now to me, at least. I think that's the right one. Yeah, okay. It's still a bit IPA in, so let's get drunk by evaporating this. All right, sweet. Can anyone go back in the stream and find out where I put the chip? I'm not joking. Fuck, did I put the chip that I'm trying to put back on here? Can't have gone far away. It's literally, I don't know how that happened. It's on the tip of my finger. All right. I might clean the chip up a bit, because why not? Can't hurt. Just so I can see the labeling a bit better instead of looking through flux revenue. All right. We seem to have a pretty clear dot on pin 1, which was that way. Let's get you in the camera where you can see this. So let's align the pin 1s. That seems to look good to me. I just need to put that there, which you can't see because of my picture-in-picture, which honestly isn't helping. Thanks, Christian. I appreciate all of your support. Please choose your deity of whatever to pray to. I'm going to apply a lot of fluff and a lot of heat and just hope it smooshes together. And there's still no question of whether this will actually fix the thing, but I've been meaning to do more soldering practice on smaller packages because I keep on getting excited by things that I see on DigiKey, and then they realize they come in the world's tiniest packages. I saw this RF analog switch that I really liked, but it only comes in flip chip, not even BGA, flip chip. So I figure practice will get me some more confidence, even if I don't actually fix this. Get it approximately aligned. And heat. And watch me blow this chip off the board. No, I think we should be okay. Oh, I was joking. Let's turn the fan down. Damn. That was supposed to be a joke, but I guess it comes from experience. Was that my eyes fooling me, or did you just go loop and solve surface tension itself into spot? I mean, you have a worse view than me, so I don't know why I'm asking you. I might just give it a little nudge if I have the muscle capability to do small nudges. Ah, why did I do that? Oh, I just made it much worse. I was probably fine there, and I probably should have let it cool down. And I think it's riding on a hump of solder, probably on the thermal pad. I just pause for a second. I mean, this looks like I'm off by like half a pin on this side here, but it's really hard to tell. I'm going to clean it up, see if it's even stuck down at all. It is stuck. Let's go closer for a deeper inspection. I'm sorry how bad this looks on camera. Oh, there's a whole mess. I don't know if you can see that. And next to that decoupling cap, there's a whole mess of balls from solder paste that have not melted. That's going to be trouble. Yeah, look, it's not bad. I can see what you guys see, but it looks better through the camera. There's less of that purple fringing and all that sort of crap. But you agree that it looks bad, or you agree that it's okay? Not the video quality, but the solder job. I mean, in this axis up here, let me get rid of some isopropyl. You agree it's off by half a pin, yeah. I think it's off by half a pin in the X direction, but fine in the Y direction for some definition of X and Y. I'm just going to get the flux off so we can see a non-reflected view. What time is it? The kids are with a babysitter inside the house, which is like a absolute treasure for me to be able to do this. Is this chip we were working on? Yeah. All right. Yeah, off by half a pin, up and down, but it's not even great left and right either. All right, well, let's get some more flux and do that again. Yeah. I'm also worried by the unmelted solder balls that are just lying around. But I think with vigorous washing, they'll hopefully go away. Now I'm going to switch to nudging it around with a needle rather than tweezers. The theory there is that when you're pinching to hold tweezers shut, it's harder to have fine muscle control. Something I think I learned at some point in my life. Because with a pointy thing, using fine motor, yes, they hold it on very well. And it'll take me a while to get this all up to temperature again. I could probably turn the airflow up, but I don't want to risk blowing it away. I might turn it up a little bit. I don't have a good sense for all the numbers and settings. All right. I believe these corner little metal things, exposed metal bits, are for testing whether the central thermal pad is connected. You can run a probe. Okay, we're getting solder melting, but this thing's not floating yet. And there's the lovely plastic from the old flux dispenser. Get off. Switch hands. Yeah, with all my clever talk of like fine motor skills, I'm also right-handed, so maybe I shouldn't hold the heat gun in my right hand because that is not the fine motor skill. I got movement, but not in the direction that I wanted. Oh, that's a lot better. Not. You know what? I'm switching hands. You know I'm right-handed. Something about doing this with my left hand feels better. I mean, it's still stuck there pretty good. I wonder if it's better just to take it off completely and start again. That way I can just place it. And I think it's now soldered itself to trying not to swear. I'm Australian. It's stuck down real good. I think those pins are slightly off. I'm not looking at the chat right now. This is where a board heater I think would be good. All right. You know what? I don't need to do that with a heat gun. Get everything nice and relatively same height-ish. You can see how it just sucks the heat out. That's crazy. Just trying to flatten it off a bit. All right. Flux again. You can't see this, but I popped it down on the FPGA and it's stuck to it. Probably just a bit of flux sticking. But, X-Acto knife. Come on. Oh no. Right. Let's see if some heat will get it off. That sucks. This really sucks. I assume it's just flux. Yeah, there we go. Might zoom in a little bit more. That looks a lot better. At least to my very untrained eyes. Yeah. All right. Am I still seeing solder balls down here? I am. I'll try getting a smaller tip on iron and just take care of those. Where's my proper tip gone? All right, welcome back. No tool? What do you mean no tool? There we go. I just want to, if those solder balls are going to melt, I want them to melt. You can see some in that via there. I mean, you can't see shit, I'm sure. But yeah, stop touching the table, stop breathing. But there are solder balls in that via. I mean, it's not a bad place for them to be, but it looks really close, but is it close enough? I might run around it with the iron. This is my finest tip iron. And just have a look and just see if it wets better. These three back here are going to be. I mean, this looks pretty good. I've already spent an hour on this. I may as well spend the rest of the time just touching each pin. Oh, I've got a bunch more solder balls there. Whoops. Yeah, I don't really worry about those solder balls being there, but I do want to make sure I've got each pin connected. You can see it's sort of like capillarying. That's totally a word. Under each pin. You can't see anything because my what's the word? I have a lens in between the camera and the microscope. Anyway, to adjust the field of view because the sensor is a very small sensor, so it's a bit zoomed in. Anyway, I think I've touched every pin. I think they look pretty good. I'm going to give this a wash and plug this in and see if we can get it to work. Maybe what I should do is take this to a sink and just wash it with water to wash the flux off. But I was going to say isopropyl is cheap. It's not actually cheap in Australia. Well, I could be biased because everything in Australia seems to be stupidly expensive compared to living in America. But I also moved here a year into COVID when there was a very strong demand for isopropyl. So this here, does that have a price on it? I bought this from JCar. I think it was like $25 for half a litre of 99.8. I mean, it looks as good as new. Let's turn the temperature down. and just flash off this board and my desk. And turn the speed back up. It's tough because, you know, the Australian dollar is not equal to $1 US. It's about anywhere between 60 and 70 cents. So the Australian dollar worth less than the American dollar. But also, like, things are just, it's stupidly expensive living here. I didn't realize how bad it would be. Like the cost of living at a farm in rural Oregon versus living in the middle of the city, effectively. We're like, you know, a couple of kilometers from the city. Expensive. All right, how do I test this? I think this doesn't even plug into new Macs because it's Thunderbolt. All right, this is where I need more inputs on my HDMI thing. But just because you're all watching, or at least still watching, I'm going to plug this in and just let you know whether it works. Let's see if it turns on. Which camera do I want? Yeah. Actually, I have a camera over here on a Noga arm that I can just move around and remember which one's which. Right. It's me looking at me. Looking at you, looking at me. Which we'll lose. Plug this guy in. Oh, light comes on. I think the first thing to do is sanity check. Hey, it detects it. Video input, HDMI. Video input. Component. Save. All right. You think I'd be able to generate a component video signal pretty easily given all the crap I have here. The fire truck, pretty much every day my son breaks a different toy. Yesterday I was fixing his forklift. And I didn't make a video of this, but I'll share it with you anyway. But he had this really cool traffic light at school. So I thought I'd make him a traffic light, and I did. It's all discrete electronics, 555s, 4017s, controlling the speed, the brightness. There's a button that if once the light turns red, you can request green. It doesn't switch to green immediately. It has a delay in it. The only push button that I had, that autofocus. The only push button I had was a normally closed push button, and I needed a normally open. So with all the lovely work with diode logic and capacitors and MOSFETs, there is a PIC chip in there that turns the normally closed switch into a normally open switch and implements a delay after pressing the call button to make it go back to green. And the delay, if he times it in seconds and converts the seconds to ASCII, spells out "Daddy loves you." But I don't think he'll work that out at 4. But yeah, I don't know why it's in here. It should be in his room. Let's see if this thing works. component video source. I have component video streaming all time out of this thing here. I probably could have test pattern up in a second. Is this computer even on that it's plugged into? Yes, all right. Let's see if I can remember this password. All right. Okay, I'm logged in. So that means out of this, if I switch to where is, okay, I'm pretty convinced that out of these three holes on my desk, which you can't see anymore because I've moved the camera, you have a component video signal. I just need a long enough wire to make it go from A to B. Okay, I'm just grabbing some BNC to RCA because I don't think I have a long BNC cable, but I probably have a long RCA cable. And that's RCA on that end. Long RCA cable, where would you be? In a box labeled long RCA cables. All right. That's not a long RCA cable. But even longer somewhere. This is the input side over here. Video input component. I'm pretty sure I'm putting component out. What source are we getting this from? Media Express unexpectedly quit. Let's just test that we are actually outputting a video signal out of this hole of a man, I wish I labeled all of these before I unplugged them. All right, there's definitely a test pattern coming out of this long cable. It is 1080p. Let's have a look. What frame rate is it coming out at? Super smeary video. Huh, interesting. Before I just shoved shit in that signal, I should at least have put a multimeter over this. Sorry, you can't see me. Let's just take a resistance measurement. I'm not very well framed. I'm just excited to see whether this thing works. It's showing 75 ohms, but so I'm going to go like this so you can see my screen. This is really high-tech video conversion here. So here is the analog video coming out. It's just the single channel. You really can't see that. It's all blown out. So it's black and white. As soon as I plug it into the guy I was trying to fix, the video signal drops out for a second. and it's got, look, it's on a long cable and it's a fast signal, so it's got some ringing happening and some like stray capacitance, but yeah, anyway, let's get this camera. Hung up again. And pointing the right way. And how do I change? All right, so we've established we have video coming to here. It's component video. So if we run this program, we should be able to see the input. But we cannot. So maybe that chip wasn't fried. Or maybe it is fried now after what I did to it. I'm going to stop and have a ponder, which I will do off camera. I'm disappointed. I was kind of hoping that this magically would work, but it didn't. How can I get my disappointment on camera? There we are. Disappointed me. I think the soldering job was reasonable. I'm going to trace the front end of this. I did it before, but like, as I said, I shorted this guy out by connecting it to line voltage accidentally once. So something's got to be fried. That chip being fried made a lot of sense. But maybe, I don't think there's a lot more in the input signal path. And out of that chip is all digital. And if something digital fried, I don't know what to do. Anyway, thanks for watching. I'm going to go ponder offline. Everyone have good weekends and stuff. See ya.